All right, guys. So any questions? I had a few questions earlier in office hours. Anybody have questions from stuff you're working on, stuff that I looked at? Anything?
On the homework, when it says correct, does that mean we don't have to redo it?
No, it does. It's not a good like correct. It's a short way for me to say correct mistakes because you see how it says
Okay.
yeah. So I'll say okay at the top, and it'll say complete. It'll have a little check mark in your grades.
Okay.
It's good, yeah. So you don't have to redo the whole thing. You just redo the parts you got wrong. And for example, a lot of people left the key off in section 2.1. So if that's the only thing you did wrong, you just write the key on there and put like correction on it. You know, you can just write it on the original paper if you want to, if you can make it really clear what the new thing is.
Okay, makes sense. Thank you.
It's my favorite phrase in the world. It makes sense. Okay. Have I talked to you guys about, I've made a plea, I can't remember if I made a plea to this class, if anyone is able to turn their camera on to do so. It just makes me feel better. I miss being in a classroom with actual faces looking at me. If you are in a compromised position or something or whatever, you don't have to turn your camera on, but see? Yay. People, I'm talking to people. I'm not just, well, I could still be insane, I guess. You could all be in my imagination, but this makes me feel a little bit better. Oh, can somebody tell me, there's a question in the homework. Why does the relative frequencies have to add up to 100% or close to it, in case we're rounding? Why is it a problem if it doesn't come close to 100%? Why should it be 100%?
That means you accounted for all the data points?
Yeah, that's a beautiful way to put it. You've accounted for all the data points. There's other ways to put it. I pretty much say something sort of like that. So you didn't lose anybody because it's less than 100%. You didn't create any people because it's not more than 100%, right? Does that make sense? I had a private chat come in. If you are a shy person that doesn't want to talk a question at me, you can chat a question at me. That's fine. You can privately chat it to me. I can take it. Anything else? Any other questions from homework or general questions?
Do we ever go over the quizzes in these classes or no?
Oh, like questions from the quiz?
Yeah, like if you notice one has like a lot of like problems or.
Well, I mean, the day that I see the class after I've graded a quiz, I will bring up general things that I see. Was there something you had specifically you wanted to talk about? Who's talking to me? Is somebody still talking to me?
Sorry, that was me. I just wanted to pull it up.
Okay.
I was wondering if we could go over number 3. Would that be okay?
Yeah, let's see. Let me pull this up here. Where is it? There it is. Okay. Number 3 was the what level of measurement, right?
Yes.
So what gets me is somebody like 3A. I'm not going to speak directly to either of these except for what I'm about to say, because you can make corrections. I'm not going to do your work for you. So I will do some stuff like this. But what gets me is when people say it's numerical data, and then they say, therefore it's nominal. That makes, I mean, I know the beginning of the word nominal sort of sounds like the beginning of the word number, but that's about where they stop. Because what the hell is nominal data? What is nominal data? It's just what?
Like names. Information.
Information. Okay, everything's information.
Like names.
Names. Beautiful. So if you know it's numerical, you automatically know it's not nominal, right? So, or ordinal. Those are the two that are sort of qualitative. So 3A, the most I'll tell you is it's either ratio or interval. And so if I said well, this is pretty much going to give it away, but if I said the number of woodpeckers in a tree, how can you tell if that's interval or ratio? So don't just say, if there's 7 woodpeckers and then there's 5, 7 minus 5 is 2. There's 2 more woodpeckers, it's interval, I'm done. Because that might not be the highest level. Is everybody semi with me? Anybody not with me? Okay. So if I said number of woodpeckers in the tree, how do you tell if it's ratio? How do you rule out if it's ratio? Some people just tell me 0 means what it should. That's not good enough. What should 0 mean in this case?
That there are no woodpeckers?
Yeah, so if somebody wrote 0, it would mean that there were no woodpeckers. You could stop right there. Say it's ratio because 0 would mean the absence of woodpeckers. Does that make sense? I mean, that's more help than I wanted to give on 3A. I basically just did 3A for you, but I'm sorry, 4. No, yeah, 3. And then here's the thing about part B that I will say. The percentages I give you don't mean shit on that problem, because level of measurement relates to data, relates to the variable and the data for the variable. What was it I was asking people on 3B? You don't have to know specifically, but what was the general idea of the question I was asking on 3B?
Was it their political output? Is that what it was?
I love how you went to politics. There's nothing about politics there, but
Agreeing or disagreeing?
yeah. And then you just got to think, is that numerical data? No. Is it just names, or is there an order they need to be in? All right, that's all I'm going to say. Is that enough there, Shelomar?
Yes, thank you.
Sure. Okay. Yeah, nothing's off the table when I ask for questions. I'll tell you if you ask me a question that I don't want to answer. I'll tell you. I'm going to have a good reason. Anything else before we get back into it? No, Jeff. Okay. All right. So what I have done, let me, all right. So today what we're going to get into, we've covered measures of relative position. That's percentiles in box plots. We've covered measures of center. So let me ask you this. I don't know why my AC is so loud all of a sudden. What am I going to ask you? I don't know. So you guys are aware, of course, of a certain website called, I don't know, Rate My Professors. Have you ever heard of that website? Yes, of course. And I remember the first time I heard about it was on the East Coast. This is a good 15 years ago. And some of you guys are like, oh, I was 3. Shut up. And the next day after the word spread, I could tell which of my colleagues had rated themselves. I love it. Anyway. So there's another website that actually has more useful information. There's another website that gives you the grade distributions for instructors. Because one thing that students don't realize is that's public domain knowledge. You have to pay a little money though, thankfully, but you can get that data. So let's say that you check out Rate My Professors. There's 2 teachers. They both teach at the same time. They're both, everything else is about, the Rate My Professors is almost identical. You with me? But let's say you go to this other website and you find out that they both give an average grade of C. And in fact, let's do one more thing before I go too far. Let's pretend we're at university. What's the difference between university and community college? What's the lowest you want to get at community college? Do you guys know this? What's the lowest grade you want to get?
B? Maybe?
I think you said C. C is the only one that'll transfer, right? At university, you can get a D- and still that's a passing grade. You guys realize this? Next time you drive over a bridge and you wonder, what did this bridge maker make on their final exam? Anyway, don't think about it too much. So you're in university. You have these 2 professors, right? 2 professors, and they're both the same. They both give out an average of a C, but one professor, you find out the spread of the data. right? And this is sort of like what we got into a little bit last time. You guys remember last time looking at the data, they were all 13, and it's like, all right, Jeff, whatever. We talked about the spread, that's the difference. So let's say one professor gives, the spread of grades is anywhere from B down to D. You with me? And another professor, that other professor gives anywhere from A down to F. Let me just ask this question. Which professor would you take?
The one with the higher, like, percent of grades?
No, they're equally, everything else about these two people is exactly the same. The only difference is one gives B's to D's and the other one gives A's to F's.
Doesn't give Fs.
So I love how some of you guys are saying the B to D teacher. Why are you saying that? Because we're a university and the only failing grade is an F. I am going, well, to be honest, it would depend. Most of the time I go A to F because I normally go into a class just knowing that it kick its ass. And I'm like, I had a teacher once, the highest grade they ever gave, anyway, was a grade I got, and it was a B. This guy was waiting for some deity to come take his class, and then they would still get an A minus. All right, you guys with me? So if you go far enough in school, you will run into these professors that never, A would be perfection, like you belong in Valhalla, or I don't know. You with me? I don't even know if you know Valhalla is. Yes? Okay. Yeah, so if I know I'm going to kick that class's ass, I'm going to take the professor that will actually give me an A. If I think that class is going to kick my ass, I'm going to take the one that doesn't fail anybody, right? You guys with me a little bit? Okay. So that's just another example of why it's important. This is one more piece of information. If I know the mean, that's good. But if I knew the spread also, I can make more decisions without having to look at all the data, right? Don't give me a list of all the grades. Just tell me the mean and the spread. And then I can make some decisions, right? Does that make any sense at all? I love it. Some of you guys are like, you lost me at hello. All right. So let's get a little more mathematical instead of something about hypothetical clones of teachers. I do have a handout that I put on Canvas that I haven't activated yet. So as soon as I get to a certain point in this lecture, we're going to go there and you guys are going to do some work yourself. I'm tired. Okay. Stay. So let's say I'm going to give us two sets of data. So set A, let's call it set A, is 3, 5, 5, 5, 8. No, sorry. So I don't want to make this too gross. Right? So copy that down. And then data B is what do you got, Jeff? 2, 3, 5. Oh, you can do it, Jeff. Can you do it, Jeff? I don't even know anymore. 7, 8. Sorry. Yeah. Okay. I really think I should have made another thing of coffee. All right. Nothing amazing here. Not much to see here. Can you guys take a quick minute, or maybe less than that, figure out the mean for both? What's the mean for both? And I'm going to do something really weird, but this is completely allowed. This is completely possible. These are two populations, believe it or not. I can have a very small population. Of course I can. So these are populations. To see who can use the right symbol for your means. Oh, let's see. I think that Albert's giving me an answer. Yeah, the mean for the first one, what symbol should I use?
U.
Excellent.
Little mu dude, right? Little Greek symbol mu, little u with an extra leg. So then what's this mean?
5.
That's crazy. Okay, so that's, you can see I'm illustrating my earlier point. They both have the same mean. But the difference is like we saw last time. One is more spread out than the other one. Obviously, which one is more spread out away from its home?
B.
B.
B, obviously, right? B is definitely one that gets away from home more often. So if we're going to create a number that will measure the spread, that number better be bigger for B. It better be bigger for, there's a lot of B's. It better be bigger for B, right? Obviously. And if it isn't, we'll throw it out, we'll go home, or we'll, I guess we'll stay home. God. I'm going to modify all my little jokes I make. We're home already, joke. I know, okay. So here's what we're going to do. This is going to be a little painful. Maybe, I don't know. I'm just going to watch for the most part. I'm going to get you guys to help me out a little bit. So let's really identify what the shit spread is, right? Shit spread, that sounds terrible. What should spread be? Why is the second one more spread out? And I basically gave it away last time. Why? Why is the second one more spread out? Why would you say that? You guys all agreed to that. Wow.
Because there's not a cluster of 5s.
Oh, okay, okay, that's true. But even if, what if I would have made this 4 and this 6? This would still be more spread out, right? High, low, even that, remember, all right, I could have made these the same and it would still been more spread out. So the thing is, I like your answer about cluster, by the way. You're not entirely wrong, but it doesn't have to be cluster. It's just that this one gets away from its mean more often, or the average distance. Let me say, I'm just going to jump to it. You ready? The average distance from the mean to all the data points is bigger for this one. That's a more technical way of what I was saying when this one gets a little further from home, right? The average distance from the mean to all the data points is bigger for the second one. Yes, Shalimar. It's going to eventually be called standard deviation. You got it. Standard deviation is crazy important, which is why I want to take you through this journey. Instead of just giving you the formula, I want you to see the formula get created. This is going to be like watching sausage get made a little bit. You guys don't get to see formulas get made too much. We give you a formula. We talk about why it makes sense. We're going to develop this formula from scratch. So let me write, I'm going to do A. So let me write these data points down. So what's a good first step if eventually I want to find the average distance from the mean to all the data points? What's a good first step? If I wanted to figure out the average age of all the men in this class, what would be my first step? Oh, I'm sorry. Alexis got her hand up. What's up? Alexis?
Yeah, so just a quick question, and I think I'm starting to get what you say by when you say that it goes farther away from the mean. Are you talking about because in the first set, because there's 3 5s and that's the mean, but then in the second one, there's more variation of the numbers?
Well, even if, in fact, let me do this. I don't know. We're going to do this. We're going to do this. We're going to make this official right now. And it's not Alexis's fault. I'm going to make that a 4, make that a 6. Do you guys understand why the mean is the same now? I made that go down by 1 and that go up by 1. So, of course, they add to be 25 still, right? Is everybody cool with that? Is the second one still more spread out? Yes. I could make this and this the same as these. And the second one would still be more spread out. Just a little bit more spread out, right? So for example, how far from 5 is 5? None. How far from 5 is 4? 1. But how far from 5 is 3? 2. I like it. All right. So we're keying in on the wrong kind of stuff here, but that's okay. I don't mind. This is stuff we learned on Monday when I gave you data that had the same beginning and end and all this kind of stuff, right? So Alexi's got a really good point. If I want to find the average blank, I got to first get a list of blanks, right? If I want to find the average men's age, I got to get a list of men's ages. If I want to find the average right shoe size, I got to get a list of right shoe sizes, right? Okay, maybe. All right, so I want the average distance from the mean to the data points. What do I need to get a list of? Mathematically, how do I tell how far apart things are?
Subtracting.
There was a quick, what?
Subtracting.
Subtracting, yes, I like it. So if I do the data points minus the mean, let me change this, by the way. We made this change official, so make this a 4 and make this a 6. Get in there. That's my password, by the no, I'm joking. It's not my pass. That'd be silly. My password is the word password, of course. So there would go a -2. Is that cool? And there we go a -1. I'm just subtracting 5 from all the data points. That's amazing. Okay, stay with me. I know statistics is only so interesting. All right. What's wrong with doing an average right now? What happens when I try to take an average of those?
It's 0.
You go to 0.
It adds up to 0. They will always add up to 0. Whatever the mean is, if I subtract all the data points, take the mean away from each one, there will be equal amounts negative as there are positive. It'll always add to 0. Okay, thanks, Jeff. You've led us down this path to nothing. Okay, there's something we could do. One thing we could do is to take the absolute value. Some of you guys might have even been thinking about that, right? Because what's absolute value measure in algebra? Why is it always positive?
Distance from 0.
It's the distance. And that's exactly what we want here. The problem with absolute value, and not to get too deep into this, does anyone know what an absolute value looks like when you graph it?
Looks like a V.
A V. I love it. So it would look like, is that a plane that you want to be on? Is that the kind of turn you want to take in a plane? Everything's fine. You can get up and move around the cap, and you're all dead. Everybody dead. Okay. So absolute value has got mathematical issues. Math doesn't really like it when there's a kink in the graph like that. It gets a little bit freakadelic. Is there another function I could use that would make things positive, but that won't have that curve be so... You guys can do it. What else can I do to a number to make it become positive? Doesn't have to stay the same number even. I can... Yes, Nathan's got it. So if I square it, that'll be this. This is a much better plane to be on. Everybody take their seats. We're about to make a big ass turn and we're all alive. Okay. I mean, that's much better. Much better. Okay. I like it. Although, I don't know. If I was on some airlines, I might want that just to get it over with. All right. There. So what we're going to do, now let me ask you this. Does everybody understand why we're about to square? I mean, you don't have to fully understand why the absolute value got thrown out. There's a little bit more to that reason. but I want you to realize that the absolute value function has some problems, and one of them is that kink. If we're going to square everything right now, what are we going to have to do at the end?
Square root.
Square root. Because if these are number of dogs people own, I'm about to make square dogs like I'm Picasso, and I'm squaring these dogs, and I don't want to go to your house. Little square dogs come running. Ah. You and your square dogs and your 2.5 kids. All right. So if I square, and again, we're squaring to make them all positive. I get 4, 1, 0, 1, 4. That's amazing. So now I can do it. Now I can do the average. I had to square to make them positive. That's fine. I'm going to get the average, and then at the end, I'm going to square root to kill all the squares I did. So how do I get the average of these numbers?
Add and divide.
Add them up. What am I going to add up? I'm going to add up these. I'm going to add those up, and I'm going to divide by
5.
5, which is the number. That formula, here's our real first formula. The mean formula was kind of weak, but this looks like a real full-fledged formula. Hello, formula. This is the formula for something called variance. The little symbol for you, ready? Looks like an R that ate too much. It's called sigma. Start at the belly and then put the cap on. Start at the belly, put the cap on. Start at the belly, put the cap on. That's lowercase sigma. And of course, it's sitting right next to its big brother or big sister. I don't know. I don't know biology of Greek letters. I'm sorry. So if we put the values in, what is the sum of this? What do I get when I sum these up?
10.
I get 10. I like it. So I'll be 10 over. Is everybody cool with that? I'm not going to square 10. That is a part of the thing I'm adding up. So the sum of these squared is 10. So this whole thing gets replaced by 10. That is something big that you guys have to get over. I know in algebra, we're so used to replacing a single letter with something. Now we can replace an entire frickin', what is the sum of these? 10. Replace the whole damn thing with 10 because that's what it is. And of course, n is 5. Oh, I'm sorry. I focused so much on making the little r fat, it's squared. Because I haven't done what yet? The thing we said we had to do earlier. I haven't taken a square root yet. I like it. All right, so if I take a square root, I should get that. Is that all right? Is everybody? I don't know. I have too much fun with being really as creepy as I can be. So that by itself doesn't mean much of any shit to us at all, but it's like it's a average distance. So this is 1 away, this is 2 away, this is 1 away, this is 2 away, and this is 0 away. So that's a rough gauge of the average distance away. So again, remind me, the standard deviation, it measures the average distance from the mean to all the data points. If you think about it, that makes sense that that's what is the spread of the data. So we're gonna do the second group together, and then I've got a thing I'm gonna put on Canvas that I need you to work on yourselves. Yes, this symbol here is variance. And this symbol here, after I take the square root, is the standard, oh shit and a half. Standard deviation. All right, so I'm gonna kind of quickly do the other set of data, and then I'm gonna let you guys work on the handout that I've got up on Canvas. I just haven't activated it yet. Any questions on that? I'm gonna take this away now. Okay. So I'm just gonna do this. All right, so now if I put this data down, let me put up here, sigma is 1 point, you crazy, 1.414. So if you had to make a guess as to what this sigma was gonna be, what would be a guess? What can you say? I want somebody to go, 11, it's a guess.
1.8.
Yeah, yeah, a little bit bigger than that, right? Because it's a little more spread out. It better be a little bit bigger than that, or else none of this means shit. I like it. Okay. So here, again, the mean is 5, so I'm going to get -3, -2, 0, 2, 3. I still have the same problem. They add up to be 0. So that's why we always square next. I'm going to do this a little bit quicker. 94049, and then I add these up. All right, let me stop for a minute. Is that cool, right? So I subtract 5, I square everything. Now if I add these up, I get
26.
26. Replace the top with 26. N is still 5. So that'll be 5.2. And then I take a square root. What is this again? 5.2 is the
Variance.
variance. And then when I take a square root, whatever the shit you get there, I don't know.
$2.28.
2 point. And here's one thing about, you ready? This is a huge note to take. Standard deviation, you have to round it to at least 3 decimal places. You round standard deviation to at least 3 decimal places. So considering you didn't know that before, tell me one more time, what is it?
2.280.
Oh, really? Cool. Sorry. So that was a little mean. So it's 2.280 whatever. Okay. I could do it myself, but I'm exceptionally lazy. Let me see. Yeah, I agree. Cool. The next number's a 3. I'm with you. So that'd be 2.280. So it matches up with what we knew should happen. It is definitely bigger than that one was because the second one was more spread out. That makes sense. All right, I like it. So I'm going to let you guys finish copying that. You had a lot more to write because I just had to fill in stuff.
I have a quick question.
Yes.
So when you're going from the sigma squared equals 5.2 and then you get 2.280, is that where you're doing the square root?
Yep. So you take a square root to get there, and take a square root on the other side to get there. I like it.
Got it. Thank you.
All right. So everybody got that? somewhere. Okay. I'm not sure, Jenna, explain your question real quick. It's not a question of what I want. It's just a question of what they are. I mean, it depends on the situation. If I wanted to hire a company to create precise little screws for this machine that I'm using in the X-ray center at my hospital, do I want the parts to have a lot of standard deviation to them? Or do I want to hire a company that has a smaller standard deviation in their parts? Yeah, I want them to be more precise. So it kind of depends on the situation. Just like we saw earlier, some of us wanted the teacher with the larger standard deviation. Some of us wanted the teacher with the shorter standard deviation. It depends on the situation. I think that's what you're asking, Jenna. I might never know. Okay. Yes, okay. So if you will go to Canvas right now, there should be a standard deviations worksheet under Unit 2. The Unit 2 module, right? So if anybody needs me to show you where that is, maybe I'll just do it. Shaboo. So if you go to Canvas, you hit modules, standard deviations right there. So what I've got in here is I've got a two-sided handout. One side is completely worked out already. Oh, I always do this. I always do this. It's amazing. Today it was in my head. I'm like, I'm not going to do it this semester. And then I'm like, it's tradition. I'm going to do it. So let me stop sharing for a second. So everybody got what they want from this? Okay, what is it that I said these were? These were populations, right? The reason I made that distinction is because if I have a sample, the formula is going to change a little bit. And the symbol I use changes, right? In fact, if I had a sample, what would this symbol be?
X bar.
X bar.
X bar.
So this is a little harder to do. I've never done this over Zoom before, but so on my screen, I see rows of people, and so should you probably, right? Unless you're on your phone, I guess you have to scroll to see people. If I randomly picked a row and calculated that row's average age, would the people in that row be closer to that average, or would they be closer to the actual average of everybody? That's a weird question, I know. Let me say it again. If I took one row at random, calculated the average age of everybody in that row, would the people in that row be closer to the average age of that row or to the average age of everybody?
Of that row.
Yeah, and it should make sense because that's the average that was calculated from them. So if I happen to pick a bunch of younger people, their average will be lower, closer to all their ages. Of course, that's why it is what it is. It's because of their ages. So when I take a standard deviation of a sample, the answer I would get if I used this same formula is going to be smaller than it should be. Because when I take a sample, am I getting the real mean from just a sample? No. So what we do, so everybody got a basic feel for why, if I take a sample, I'm gonna have to adjust it somehow. And that's my explanation about why there should be an adjustment. You probably understand there's more to the story, but that actually is a good chunk of the story right there. I'm gonna assume everybody's got this. So what happens to the formula, so let me write this. So here's the one for population again. And so for a standard deviation of a sample, one obvious thing is this becomes X bar. That's not anything amazing. Of course it does. But the other thing that happens is that how do I make division, how do I make the result of a division come out bigger? What do I do with the, I'm sorry. Yeah. So let me start over. If I use that same formula for a sample, the standard deviation will be smaller than it's supposed to be. So what would I do to make this division come out a little bigger to overcome that? Hopefully you guys are with me. I would divide by more or divide by less to make it come out bigger.
Divide by
Less.
You divide by less.
I divide by a smaller number, my answer is bigger than it would have been. So what's interesting is it turns out I divide by n minus 1. And that's not going to be a Greek letter anymore because I just have a sample. So that Greek letter becomes X. This Greek letter, not surprisingly, becomes S because that's the Greek letter S. So it just becomes S for standard deviation. Yeah. So you can put those two formulas down to reference. So over here, if this would have been a sample, I would have divided by 4 there. That would have been the only difference in all the work we did. Okay. All right. So everybody got that? Let me see. Looks like some people still copying. I am going to come in the way. So now if you go to Canvas, so everybody that can access Canvas, you found this. So one side is a completely worked out problem with the same questions answered for this data. The other side is the one you got to work on yourselves. Notice this. I want to do this with you also. Let me show you how to get the calculator to do a lot of this work for you. All right. So hopefully most of you guys have this where you can access it. I'm gonna stop sharing for a minute. Let me show you how the calculator will help you. Where are you, calculator? There you are. Here's your calculator. And which, of course, was the button, the important button, most important button, besides on. Stat, thank you. I always got to get there before my smart asses get there. Go to edit. Let me clear this. All right. And then I'm going to put in there 12589. That's the data from that one side. So let me put in there 12589. Now I want the second list to be all my data values minus the mean. And here the mean again is 5. Are you guys with me? So look what I'm doing. Look what I can do. Go over to L2 and see how it's waiting for me to tell it what the hell L2 is. This is going to be really useful the whole semester. I can tell it L2, where are my X's? Where are my X values? Kind of a silly question. L1, it's the only other place there's anything. So it's got to be L1. So I can tell it second one. I can tell it it's L1 minus the mean, which is 5. And if I do that, the whole freaking thing gets populated. Maybe. So, I mean, for 5 data points, it's not very useful, but can you imagine, I don't know, if I gave you 32 data points, wouldn't that be very nice? All right, I like it. And then if I go over, what do I want to make L3 be? This is my X, X minus the X bar. What do I want to do with that now? What did I have to do with it? Square it. So if I take L2, second 2, if I take L2 squared, and be really careful. So that's what it should look like. Just in case, let me see if anybody's getting this. Is anybody getting an error like this? Did anybody get that error? No? What I'm doing, see how it says data type? I'm trying to put, if I say go to, I'm trying to put an entire list into one spot. There's no way I can do that. I got a couple chats. What's happening? Shit, why won't my chats open? All right, somebody is trying to tell me something and I cannot, it won't let me see it. I'm gonna have to stop sharing. Oh, okay. You got it. All right, that's fine. All right, wait a minute. Let me come back here. Yeah, so if you got the error, it's easy to correct. You go up to list 3. You want to define list 3 to be list 2 squared. You can't define one spot to be a whole list. Calculator freaks out. Thankfully, it don't blow up. It just says error. Maybe. And then finally, the last thing I'd want to do is to add all this stuff up, right? So in the event that this is very long, let me show you how to add these up. Go to second mode to quit. Go to quit. Do you see what it says above stat? I'm going to assume you do. Nobody wants to talk to me today. That's all right. So if I hit second stat, I can now do stuff to my lists. So what do I want to do to list 3? I want to sum it up. So I want to do math to list 3. I want to sum list 3. So if I go sum list 3, 50. Do you have to do it that way? No. Is it smart to do it that way? Yes. All right. I don't see
Can you
anybody
share
else.
that again?
Sure. So let me kind of start over again a little bit. So over here we got the L1 minus the mean. Bam. That's where those came from. Then I go to L3. I want L2 squared. I got to square those things so that the negatives become positive. Then I'm going to get out of my table, second mode to quit. And now I want to do something to the lists, right? Right there where it says list, I want to do something to one of the lists. So hit second stat to get to list. I want to do math to my list. I want to sum up. You could just hit the number 5. I can sum up second 3, list 3. I can sum up list 3. Bam. So that's how the calculator can make some of that work quicker. So now what I need you guys to do, I'm going to stop sharing. Let me bring this up. Where are you? Oh, man. Hold on. Error. Oh, there you are. That's not you. I closed it. Who's talking to me? Okay, hold on. Let me pull that up. I'm just going to pull it up this way. There it is. Okay. So are you asking me, person chatting to me, question number 2, question B. Okay, wow. Wait. What does the line on top of the X for variance mean? Oh, wait a minute. You mean the X with the line over it? What does that symbol mean right there? What does that symbol mean? Sample
Mean.
sample mean. It means sample mean. So it's the mu we had earlier was population mean. X bar is sample mean. All right. So what I need you to do now is I need you to do this. You can download the sheet if you want to. You don't have to. So I need you to work on this. And don't round your mean. I think I kind of made a big deal out of that. if you think about it, if you round your mean, your standard deviation is going to be wrong, because now you're doing a distance from your data points to something that's not the mean. Okay. Very hopeful. I'm going to stop recording, I think, if I can. Yes, pause. All right, so let's take a look here. Just remind everybody, here's my calculator. Let's get what we need. All I really need from this is the sum of list 3, right? And I understand, by the way, so I understand, I think a couple people have a calculator and it like died on them. That sucks. Some people might not have a calculator at all. That more than sucks. You need to have something. But if I want to get the sum of list 3, I can hit second, quit, get out of here, and then just do this. So I've already done it earlier. So just to show you again, second stat to get the list. I want to do math on my lists. I want to sum up my list 3. There you go. So let me switch over to the worksheet. Where are you? There you are. All right, can everybody see the worksheet now? Worksheet. Yes, thank you. All right, so if I put, all right, this is gonna be interesting. So let me just put this in real quick. I don't know if anybody did this. This should have come out to be 0, like it always would. This, you needed to calculate the average. I can't remember what this was, but this one was what we just got. Everybody should have got 6.5 as their average, right?
Yes.
So what would that be? 6 times 13, 78. Is that what the sum of the x's was?
Yeah, 78.
Okay. All right. So now, if I just plug in, so this whole thing gets replaced with what?
69.
69. I like it. And then n in this case was what?
11.
12.
12, and then 12 minus 1, 11. I'm
11.
with you. So you get, for the variance, you get 69 divided by 11 is
6.272.
3.
ooh,
6.273.
272727.
Yes.
Okay. Become a 3. All right, and I want to show you something on the calculator real quick. Oh, geez, I can't do that. Too much technology. All right. Let me show you something. So if you do, let's see, what did we just do? We just did 69 divided by 11. And I get all that, right? You shouldn't round until the end of a problem. So watch what I can do. Watch what I can do. I want to take the square root, and this is one of the coolest buttons on here. Do you see right above the negative, there's an ANS button? And that is the quickest memory location that always has the last number that showed up on the screen. So if I do second negative, square root of the answer I just got, so then I don't round too much and I don't have to rewrite all these freaking numbers, right? Very useful. Okay, maybe. Is that what you guys got for the standard deviation?
Yes.
Good, because that's the
Real
rate.
quick, show us how you did that trick again, please.
Yeah, so let me do a 69 divided by 11. And then I can do the square root, right? There's a square root. Second negative to get to answer.
Okay, thank you.
A-S. So now if I do, for example, this has nothing to do with this worksheet at all, but if I did 2 times answer, can somebody give me an estimate of what that would be? Because what's in ANS right now? This is.
Yeah.
So the answer should be about 5, right? So it's always the last number that shows up on the screen is what is now in that memory position. That is very, very useful. Very, very useful. Okay. In fact, look what it does. If I just hit the minus key, it assumes I want to subtract something from the last thing that was on the screen. So it puts that in there for me. If I hit the divided key, same thing. It says, oh, you mean you're a silly human. I think you mean to divide the last thing. Anyway, okay, that's enough of that. Sorry. Where was I? There. Bam. Now I use this technology. Bam. All right, so now when I take the square root of that, you get, what was it again? 2.50.
4, 5.
So what would I put here? 4, 5 would be okay. But I could just put 5, yeah. So it's got to be at least 3 places for the standard deviation. Now, here's the thing about standard deviation, guys. Real talk, kids. It's sort of like the standard deviation is the measurement I'm going to use for my data. So if I was talking about, if we were in the classroom and I was talking about distance between 2 people, I'm not going to use miles. Are you with me? Right now, I'm going to use miles, most likely. If I want to talk about the distance between two students, I'm probably going to use miles. Does that make sense? Yes? So in different situations, I want to use different units of measurement to measure distance. The standard deviation is the way we measure distance in statistics. How far away is one data point from the center? So that's what part C is getting at. Part C says, if I have a data point of 8, so if I made an 8 on this quiz, how many standard deviations away was I? Now think about it. If it comes out positive, that means I scored above average. If it comes out negative, that means I scored below average. Now in this case, the average was 6.5. So it's going to become positive. But what do you guys do? What do you guys get when you do? Oh, look at me. I'm going to make that official in a minute, what I just wrote down. What is that? 3/5. Is that like 0.6? Something? Something close to that?
0.6.
Is it 0.6? Yeah, okay. I was just questioning my 0.6 exactly? That's neat.
It's about 0.6.
Give me a couple decimal places on that one.
Oh.
Oh, really? So it is 0.6 up. Okay. All right, sorry.
0.598.
Ooh, do it again.
0.598. Or
Ooh, 598. I got you. Which is basically, yeah, okay. I'm with you. All right. So what this is, so if you put 0.599, I would take that also, I think. This thing right here is called the Z-score. So the Z-score is like me saying I live about 7 miles away from my friend Joe, right? Z-score is a unit of, it's a way that we measure distances. So this is not very far away. It's not even a full step away. So I often think of standard deviations as steps. It's like 0.6 of a step away. It's not very far away, but it is above average. Okay, maybe. Okay. We're going to do a lot more to do with that, but I just want to lay that groundwork now. This is where things get really kind of weird. The mean was 6.5. If I go one step up, that's 1S, by the way. My freaking, let me make this a 1. 1S. If I go one standard deviation up, where do I end up? It's pretty cool with what's happening. If I take, yes, yeah, go ahead, sir.
9.003.
003.
It's 005.
Yeah, 005. Okay. Or 9.0 is fine. Yeah, 9.005. I like it. And if I take, is everybody cool? I just added one standard deviation. Let me subtract 1. Let me go one step down. Where do I end up?
3.995.
I like it. Now, that is within 1 standard deviation of the mean. How many data points are in here? And this is where if you sorted your list, it would be useful, right? So if I look back, uh-oh, somebody's chatting at me. Oh, really? That's neat. Let me stop sharing for a second. Sorry if you're looking at that. It's too bad. Ha 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 ha. Come back over here. So if I look at my, I can go in and sort my list real quick and make this nice and easy. I don't need all that shit. Sorry. Stat, sort, list 1, stat, edit. And now I can see how many things are between. I have 0 memory. What was it? 3.9 so starting at 4, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, so whoever just chatted 9 at me, you're right. Everybody with what's just happened? So let me come back to the paper. Where are you, paper? So I just went and counted how many data points are in here. So that would be from 4 up to 9. So there are a total of 9 data points in there. Out of what? How many total data points?
12.
12. So what percent?
75%.
75%. So 75% of these grades were within 1 step of the mean. So I would say that that data is pretty tight to the mean. There's a decent amount really close to the mean. So that's one of the most fundamental things we can do with the standard deviation is that type of thing. This kind of question is going to show up basically on a lot of things. Holy crap. This question is going to come back over and over and over again. So let me ask you this. What time we got? Okay, not too bad. Can somebody tell me, what does a z-score tell you then? Look at the question I asked. What does a z-score tell you?
Distance.
Okay. But that's not good enough. That's good enough for like us just discussing it really quickly. But if I ask this question on a quiz, for example, I don't know, I might do that. It's a very good chance that that exact question will be on a lot of quizzes. I'm going to ask you the hell out of that question. So I'm not sure how to make this more obvious that this is a really good note to take and to really understand, because z-scores are insanely important. So what a z-score tells you is the number of standard deviations from the mean to the data point.
The distance from the mean?
The number of standard deviations, from the mean to the data point. So I really want this to make sense. How can I measure distance from me to the school? I can say it's the number of miles from me to the school, right? Couldn't I say it's the number of yards from me to the school? Does that make, that's still good, right? You guys with me? Yes, maybe? So the way I measure distance between data points and the mean is in standard deviations. I don't use inches, I don't use miles, I don't use yards, I use standard deviations. They're like tick marks on a ruler. But it's not inches, it's standard deviations. So if your height, now let's think about this. If you had a height that was 3 standard deviations above the mean, are you very short? Are you very tall? Are you average height? Somebody's shouting at me. Okay. I can't handle so many things. You are really, really, really tall. Yes. We will learn later that once you get 2 steps away from the mean, you have caught a lot of the data in there. Because 1 standard deviation is the average distance from the mean to every data point. So if I do 2 of those, I really should catch a large chunk of the data. So if I go a third step out, holy shit, we are talking large, right? We're talking, I don't know if anybody knows who Manute Bol is. If I say the name Manute Bol, does anyone know who that is?
Go Denver.
There you go. So, well, I don't know. Are you thinking about, what game are we talking about?
All I'm talking about is not Minute.
All right, I thought maybe you had it mixed up with somebody else. Who's chatting at
No.
me? Basketball, there we go. Good job, Riley. Manute Bol played basketball. I think he was 7'7". I can't remember exactly.
7'6".
7'6"? Okay. I gave him an inch. All right. I came off a flight, a Southwest flight, and I looked over and I saw this big crowd of people, and then I saw Manute Bol's head basically just over everybody else. So everybody was crowded around him because he had just come off a flight. Anyway. So his Z-score height would be like 3 point something. He's crazy tall. So once you get outside 2 steps, that is what we call unusual. Data points outside of 2 steps would be considered unusually blank. So if you have a Z-score of 3 for a height, you are unusually tall. If you have a Z-score of -3, you are unusually short. And we're not saying that in a mean way. It's just not something we see all the time. Because how are heights, do you know how heights are shaped? That's a weird question. If I plot all the heights of all men, let's say, I'm going to get a shape like that. And this is called a normal curve. So most guys would be within 2 steps of the middle. So these people are really crazy tall, and these creeple, that was great. Well, that's good. If I want to have a future political job, that's going to ruin it. These people down here are very short. All right, maybe. It's like Warwick Davis. Anybody know Warwick Davis? He was an Ewok, and he was in the movie Willow. If you've never seen the movie Willow, look that bad boy up and watch it, and you can thank me later. All right, sorry. Enough non sequiturs. Let me see. Pew! All right, I think, let's see, 3:10. Okay. What the hell? That's enough for today. You guys, I didn't give you any break, really, so I'm going to let you out a little early. Chapter 4 should not take us as long as I put down on the homework sheet, so we should be able to catch back up relatively easily. It's all about probability, right? So we'll discuss birthdays and game shows and other various things to do with probability next time. So officially, our class is over. If you have any questions, hang out. Let me know you have a question. Am I still sharing my screen? No.
Can you go over how you got 75% again?
Oh yeah. Let's see. Are you okay with these numbers here?
Yeah.
Okay. So all we did then was we went to the list of data and we counted how many data points are between this and this. So if you go to the data and you count 1, 2, 3, 4, 5, 6, 7, 8, there's 9. There's 9 data points between 3.9 and 9.005, right? Is that all right?
Mm-hmm.
Okay. And then you come back and you say, okay, well, how many total data points did I have? I had 12. So how many data points were in here? 9 out of 12. So there's 75% of the data points.
Okay. Thank you.
You're welcome. How's everybody else? You guys all right out there?
Could you this is relating to the homework, but could you explain a box plot to me again? Because like I'm still kind of lost.
So what do you need to calculate to create a box plot? What goes on a box plot?
What do you mean?
Okay, so I wanted to see where you were with everything. So box plots plot the quartiles. Let me stop right there. Do you know what quartiles are?
Is it like the quarter thing that we did with the quarter
So
one?
like first quarter is P25,
Right.
second quarter. Yeah, so if you calculate, the lowest data point, Q1, Q2, Q3, and the highest data point. That's what's called the
Okay.
5-number summary. And that's where we started drawing lines over the scale we make. Does that sound familiar? Yeah.
That sounds familiar, yes.
I like it. So you got to calculate those 5 things first, the 5-number summary. Oh, and by the way, since you guys are here, let me show you something real quick. It's kind of related to what you're asking. See how the data is right here? This is the last thing I didn't do. Let me just show you guys. If you hit stat, calc, 1var stats, does anything look familiar?
Yes, everything.
Everything looks familiar, Jeff. You jackass. So I love it when I have students that are like, well, why do we have to do all that shit? Why can't we just do this? Because this means you didn't learn a damn thing. You learned to push a button. And I want you to be more than that. More than a button pusher. Right?
All right.
And if you scroll down, do you see how it tells you the 5-number summary? Low, Q1,
Okay,
Q2.
Yeah,
But don't get too excited. That is a way to check your work, of course.
So when you're actually drawing the box plot, it's you have to connect Q1 to the middle to Q3, right?
Yeah, so I would make for this data, I would make a scale 2 to 10 probably, right? 2, 4, 6, 8, 10. Put a line over 2, put a line over 4.5, put a line over 6.5, put a line over 8.5, put a line over 10, and then connect the middle 3, Q1, Q2, Q3. I think that's what you said with the box.
Yeah, that's easy. I overthought it. Okay.
Okay.
Thank you.
You're welcome. Anybody else? Questions?
Yes, I have a question. So
Yes.
for when you're trying to calculate the variance, you don't want to round it. You don't want to round it yet until you finish everything.
So when you write it on your paper, you can round it. But in the calculator, you should get used to not rounding until you're really done. Yeah.
Okay. Also, can you go over C again? The standard deviation from the mean. Like
Oh, here, this one?
yeah.
So this is the formula for it right there. So it's kind of makes sense because if I figure out the distance and divide it by standard deviation, I'll see how many standard deviations fit between these two if I do that. That's what the math does. So here I'm just curious about what if I got a grade of 8? But how far away from the mean was that? I subtract it and then I divide it by how big each step is to see how many steps away it is. So it's not even a full step away.
Okay.
So that's just the formula for that, and it tells you how many standard deviations from the mean to your data point.
Okay. I got it.
Don't forget the other side is a whole worked out example, you know. So you gotta look at that too. Yeah. I might post a cleaner one of these up there if I remember it. Anybody else? You guys are right.
There's no class on Monday, right?
Yeah, Monday is Monday. Wait, Monday the
7th.
7th. I think you're right. I think that's Labor Day. I'm gonna have to remind everybody about that fact. But wait a minute, where am I? Here.
Yes.
I'm almost certain you're right. It should be on the homework sheet, right? I've got all the holidays and stuff on there.
Oh yeah, now I see it.
7th. Yeah, you're right. Look at what am I doing? Labor Day birthday. I love that. Anyway, Labor Day birthday. That's awesome, Jeff. The 7th. Yes, you're right. I'm gonna have to send an email out to remind everybody. Cool. All right. Let's see, is anybody left in here? Riley, you okay? I'm out of here.